the sixth webinar, the E.WDRI WDSA Graduate Student Task Committee. I am Oluwabunmi Waki, and I'm a third-year PhD student here at F.EWRI University, and I'm also the current chair of the Graduate Student Task Committee, and I'll be moderating the webinar for today. So before we go into the webinar, I'd like to let you all know a little bit more about the Graduate Student Task Committee and what we do and why we organize webinars like this. So we are a subcommittee of the larger Water Distribution Systems and Analysis Committee, which is within the Environmental and Water Resources Institute of the American Society of Civil Engineers. And we are mostly made up of graduate students, postdocs, and professors. And really our main goal is to bring together graduate students or students generally working within the water distribution system space to kind of allow us to network and collaborate. So we try to do that by sharing graduate research and job opportunity postings on our social media as well as our Gmail listings. And we also organize webinars like this where we feature hands-on tutorials or technical sessions and to kind of, improve ourselves pretty much. And as much as possible, we try to organize in-person events at water-focused conferences, like the E.WRI conference that will be happening later this year. So please feel free to engage us as much as possible, and we would love to have you join our community. So for today's webinar, we will be having a panel discussion with our esteemed speakers. We'll be having a conversation on Water Nexus and how they have been able to bridge that gap that exists between academia and real-world practice, real-world application in their own practice within the larger the water and wastewater utility. So after the session, we would love to hear whatever questions you have for our speakers, and we'll open the floor for such questions or whatever comments you might have. So if peradventure you have some question during the webinar, please you can drop them in the chat box and we would address them once we are done with the session. So I would like to go ahead to introduce the speakers. I would like to start with Shri, and I'd like you to tell us your role, your affiliation, a little bit about your work experience, and what you typically do on your day-to-day, what your day-to-day responsibilities look like.
Sorry. Good morning. Again, thank you for inviting me to this webinar. I think it's a great idea to have practitioners and also with the academic interact. So my background, I started I've been working at the water district here, Las Vegas Valley Water District, for the past 25 years. First 2 years I joined as an IT consultant. So my background, I have a two masters in engineering and a master's in computer science. I worked in academia for 5 years, research and at the University of Louisville. Also, I used to chase flooding and flood-related infrastructure issues. And then here at the Water District, I've been working on several things. So I have three primary responsibilities in my position. The first one is, I deal with property developers and home builders. We have been, as everybody knows, there's a lot of growth in Las Vegas. And we, in the area, so my team's responsibility includes not dealing with the property development, but also hydraulic modeling and providing technical services. So we have added about, in my area, about 15,000 homes, about 200 million. So I also negotiate with the developers how, what infrastructure we need. So which also needs some of the hydraulic analysis and things like that. So the developers invested probably about $200 million in the area that I, work in. So we just negotiate and to see how we meet capacities and pressures. We also provide technical services, my team, to in-house customers. So we provide operational supports. One of the things we also do is the digital twin. The digital twin that we have been operating the system. So our operators develop a pumping plan since 2005 every day, and then send a plan to our system, and the system runs from that digital twin. So we provide all the support and also the support for the software. We also deal with any kind of shutdown. So every shutdown in our system goes through our hydraulic model. And part of my team's responsibility also includes taking field measurements and pressures and flows from IoT devices. So we are trying to operational troubleshooting, make sure that there are no abnormal operation issues, transients, and protect assets and increase longevity. The last part of it is, we plan for the future growth, and including facility location, sizing, reliability, redundancy, and hydraulic analysis, to make sure that all the projects that intended to work the way they're supposed to work, and then we meet the future growth. So that's, and in my day, typically, I come here in the morning, and then you have several meetings with either developers or the engineers and consultants, and also internal meetings on projects. And obviously we're working on some of the technical issues. So that's my day. From morning 6 to 6, we work 4/10s. Sometimes it goes longer.
All right, thank you very much, Sri. What about you, Michael?
Thank you, and also thank you for the invitation. So my experience background, I have a master's, undergrad master's in civil engineering, and for my master's in civil engineering, that involved the study of bridge scour and two-dimensional flow modeling. Of course, when I did two-dimensional flow modeling in the mid-90s, that was a bigger statement than it is anymore. I also have a master's in engineering management. I've worked for the sewer district, Metropolitan St sewer district, just over 20 years, several positions currently as program manager for our design group, in-house design, in-house projects. And they end up being a lot of infrastructure, what we call infrastructure repair projects. So we do unusual compared to, I think, a lot of government agencies, and we have a fairly capable in-house design staff. And so as far as design construction, we'll run in the neighborhood of 40 million a year or a little better of projects we actually design and construct. Most of those are repairs. So as similar to what we just said, I manage several different programs, hence my title, program manager. So the first one come to mind is what we call our small contractor program. So it's actually a way for us to get smaller repairs done pretty quickly. And so smaller is defined as under $50,000 in construction fee. Along with that and some work for operations side, we'll do about 400 projects a year. And there, so it keeps moving. In-house design, for bigger projects over 50,000, maybe but 5 million construction fee, we'll do 45, 50 projects a year. So manage that small contractor program, which involves working with contractors directly and our in-house team to get all those administered. Also working with the engineers and CAD operators to design the bigger projects. That involves a lot of work with our planning and operations side. And then finally, in support of all that, there's a lot of administration of consulting contracts, so they can be for services we don't do in-house, but we need for design, like say geotechnical investigation or outright design of certain projects where we don't have the specialty. So we'll have like a landscape architecture, geotech general service agreement. So really, it's sort of those programs, the in-house design, the consultants, and small contractor programs. And so the day-to-day, I think what was said, there's a certain amount of meetings in every day. Those can be with our in-house staff or with consultants, occasionally owners. That I'm lucky anyway that being involved in these construction projects, I'm able to get out into the field pretty regular and do that. And then there's certainly a fair amount of time I spend worried about budgets and projects. And then probably the last regular thing I do is sort of a QA/QC work for a lot of our in-house design, and also trying to work with planning and plan out our budgets and all, our improvements and repairs of the system. Again, a lot of work we do in-house ends up being our repairs. So I think that's about it. Hopefully that's useful. Yeah, Steve, if you want to go ahead, like I said, I think that covers me.
All right, I didn't know who's going to give the cue. Thank you, Michael. So my name is Steve Niemeyer, and I have a very small consulting firm. I'm not really doing consulting now. I'm actually working at the Texas Military Department, which is where I'm training Texas National Guardsmen on how to manage hazardous waste. It's very different than what any guys are probably thinking about right now, but it's something that's kind of essential, especially when it comes to managing spills. They spill diesel, they spill jet fuel. So, any case, it's something that I do daily, and I travel all over the state, and Texas is a big state, so that's something that we do. But in a previous life, before this, I worked for the wastewater utility in Birmingham, Alabama, where I was managing the conveyance system. Basically, when your wastewater leaves your home, it hits the pipe out in front of your street all the way until it gets to the plant. That was what I was responsible for. And so there's a lot of management that goes in there. We had an asset management program. We had a company that did the asset management work for us, a lot of the work for us, an engineering firm. And one of the things, but there were a couple of interesting a lot of this was just basically routine work, cleaning out sewers, making sure that they're not overflowing, because that was one of the metrics that we had with the EPA and with who was it? The Alabama Department of Environmental Management, was how many sanitary sewer overflows did we have, and we had to report those. And that's when basically wastewater comes out of the ground, out of your manhole or out of a pipe or leak somewhere, because that's not good. And we had to report those, and my guys would respond to those and maintain the system, keep it flowing. And so we developed a system to track that. How much did we collect when we cleaned things out? What kind of materials? Was it rock, gravel, which would indicate there was maybe a break in the pipe, or grease? And, then you would say like, oh, maybe there's an apartment home upstream of that facility where maybe they were letting grease enter. They were trying to educate people on how to prevent their grease from getting in. So those were the things that we did. And then we had camera crews, and let's see, what else do we have? And then we used a couple of computer programs, software systems that were developed by a company that were dynamic. So we could predict how frequently we needed to clean out pipes and where we needed to clean them out, and which ones needed attention. And also, and the basis of that, we would determine who needed to go clean out pipes, how often, and where we need to devote our resources. And then I'll just mention one other thing because I think it's of interest. I worked at the state of Texas doing U.S.-Mexico border environmental affairs, and one of the things I did was I worked on colonia issues. And a colonia is a neighborhood. It's basically these folks were sold land with a promise that it would come with utilities. At first, we thought it was along the border, the U.S. border, the Texas portion of the border with Mexico, but it turns out they're all over the state now. And a lot of times they were just sold a plot of land with no utilities. So the legislature found out about this in the late 80s and appropriated money to get them water and sewer. And there are a lot of different issues, but you find out that, by the time I came along, we got most of the big ones taken care of. And it was 300,000 people throughout the state, initial surveys. But then we found out that there were some that either didn't have water or didn't have sewer. And the problem you had there is that a lot of times you had these issues where we got all the low-hanging fruit, but people who needed their water or sewer service, they were a long ways off. And the cost per connection was prohibitive. And I think this is something you're going to find too, just anywhere. You got to look at the utility rates because a lot of your customers can't afford or have problems paying their water. And I will tell you that, like in Mexico, legally, you can't cut off water to someone because they can't pay, because I would have to work with my Mexican colleagues on some of these issues. So that's just something for you to consider. And a lot of these were very difficult cases. Michael talked about projects under 50,000. If I'd had $50,000, a lot of times I could have done a lot of things in some of these areas. But the agency that funded a lot of these projects, the Texas Water Development Board, and they get funding from EPA and for these projects and also the state, they didn't really have dedicated funds for small projects. So that's something that I think is needed sometimes. Right. I've talked a lot. I will stop there. I'm a man of few words if you haven't figured that out yet. So
thank you very much, Steve. Thank you very much, all of you three. Yeah, again, very excited to have you with the wealth of experience you have from digital twin to engineering management, smart systems, wastewater management. It's truly a delight to have you speak with us today. So what technical challenges and regulatory issues would you say your utility has faced in the past?
Yes, so one of the biggest issues for us is, we are a water utility in a desert. So the water, availability, right? So one of the impacts, the biggest impact for us is the shortages in Colorado, or, drought, or now we call them water shortages. So the Colorado, if you look at the Hoover Dam, the full level is like 1229. Right now it's at 1066, right? We get about 300,000 acre feet out of 15.5 million acre feet that's supposed to flow in Colorado. And we have to manage 2.4 million people. And then, our entire Nevada, right, gets about 300,000. So for us, the water level right now is about 1066, like I said. It went in 2023, even below 1050. So our first intake is at 1050. So how do we manage reduced availability of water, right? So we have been pretty aggressive in terms of conservation. So all the regulations that are associated with the conservation. So we even have, how much water you can use based on the season, right? So with that, because our water consumption has gone down. Can I show the slide, or am I just with no slides? If I can share, I can do without slides too, but
Okay. All right. I'll stop sharing quickly so you can share.
Yeah. Okay. I'll show you like an example of. So here is the our population. This is for just the. So we have S.WRE, which is the whole supplier, right? And then this is only for Las Vegas Valley Water District, which is about 2/3 of S.WRE, which we also, S.WRE supplies Henderson and not Las Vegas. So if you look at the Las Vegas population, right, we have gone from 1 million to about 1.6. So we have added 600,000 people. But our water consumption has gone down from 115 billion to 104 billion gallons a year. So we added about 600,000 people, but we are using 11% less water. So we have been, as you can see, pretty aggressive in terms of conservation. So which brings a different kind of issues for us, right? So we have existing facilities that, when consumption drops, we have to use those facilities effectively in terms of my job. And also we have to, how do we take that into account when we optimize, for future facilities? And having, lower levels in, our water quality and treatment, they have to also deal with having less water in the Hoover Dam that creates different kind of water quality issues, right? So that has been, biggest challenge for us. How do we, deal and then with, the issues? So with that, I guess I pass on to the.
All right. Thank you very much, Sri.
So if
Michael, would
you take from me.
you like to share?
Thank you. Thank you. So I'm not sure how many people on the call are familiar with the term consent decree. So that's our concern. So just a little bit about St. Louis MSD, Metropolitan Sewer District. The St. Louis Metropolitan Statistical Area covers 16,555 square kilometers and has a population of 2,603,607. So 2.6 million people in our service area. This area includes the city of St. Louis, St. Louis County, and St. Louis County. That's our service area. Okay. So you can see our service area obviously covers sewers built during the Lincoln administration to infrastructure being built today, right? So we've inherited, when the district actually started in 1954, the St. Louis Sewer District started in 1954, and we inherited up the previous infrastructure, previous sewer districts, and put that under one heading. And so Steve mentioned overflows. We had in our system overflows that were actually constructed that way. That was the intent, that this sewer is going to overflow. Sanitary sewer, and all combined sewers are constructed that way, but our sanitary sewers were constructed in such a way that they would overflow before it gets in somebody's basement. So we kind of had a medieval approach where we dumped the sewage in the creek, so to speak. So we got placed under consent decree. That is the EPA. In 2007, the state of Missouri and the United States EPA filed a lawsuit against MSD regarding overflows. The Missouri Coalition for the Environment later joined the lawsuit as an intervener. So throughout MSD service area, there are hundreds of points where a combination of stormwater and wastewater discharges into local waterways from the sewer system during moderate to heavy rainstorms. Sewer overflow points act as relief valves. Too much stormwater enters the sewer system. Without them, the community could experience thousands of basement backups and extensive street flooding. So choices us made. Instead of putting all that sewage in somebody's basement, we're going to put it in the creeks. Well, with related to sanitary sewers, it can't happen anymore. So we got sued, and they told us we got to get rid of these overflows. So Though most overflows predate industry's creation in 1954, they're still our responsibility to address. From 1992 to 2012, MSD spent approximately $2.7 billion to remove more than 350 overflows. Fewer than 400 overflows remain. Of course, you can imagine the later ones are the hard ones, right? Later ones are the hard ones. So in August 2011, the Department of Justice filed a settlement decree requiring MSD to spend a minimum of $4.7 billion over the next 23 years to address this issue. That's something like $7 billion right now is where we're sitting over 25 years to read that. So what does an old system look like in the rain? Hopefully this is fun for everybody. If I could share my screen for just a second, I think you'll get a kick out of this. Okay, you can all see that. So this is what happens when a lot of rain gets in our old system. This is down in the city, so it's a complicated system, drains the Mississippi River. So that's what a system getting surcharge looks like. You can see the grades pulled out of that structure. And the one thing you can't notice here in the video is the woman standing there taking the video. She's my car. If you look at all the white stuff in there, you might realize that's toilet paper. So that's the great fun we have. Steve?
Yeah, Steve, would you like to talk about some of the challenges you face?
Yeah, thank you. I think when I was at Jefferson County in Alabama, our service area was 600,000 people. We had about 200,000 connections and I don't know, like 5,000 miles of pipe, 175 pump stations. And I was responsible for maintaining those, the flow in the pipe. And just like in St. Louis, we'd had a lawsuit and then a Department of Justice consent decree. And this is a fascinating case history. I encourage everybody to look it up. Jefferson County sewer scandal. And what happened was we had to spend so much money, the county had to spend so much money that the engineering consulting firms got involved and there was a lot of corruption and people were tipped off. The FBI investigated. When all was said and done, I think 21 people went to jail, including a couple of county commissioners. And let's see, the head of the department who was having a house built with an elevator in it by the consulting firms. So yeah, a lot of it, and that resulted because of of having to build, and we had to go out and get bonds, and then we got ripped off. The county got ripped off by the bond salesman, and in New York, the county had to declare bankruptcy. It was one of the first few bankruptcies, municipal bankruptcies in the country. And that caused a lot of problems. So all because of trying to stop our overflows in a suit by the Cahaba River Society, which is a nonprofit. So in any case, those were issues we faced in the past. I'm going to say also, when I worked for the state, we had issues getting water because we weren't the utility, but we were getting water from Mexico. And this is something you're going to find, especially in transboundary water issues, getting water from one nation to the other. And under treaty, and treaties have a higher level of compliance than they supersede national law. Mexico was supposed to deliver 350,000 acre feet a year in cycles of 5 years, or 1.75 million acre feet. But then they were waiting till the end of the cycle to give us all their water, and then they wouldn't have any water, and there was a provision that said you could wait for another 5 years. And the problem was that we had farmers who were depending on this down in the lower Rio Grande Valley. You can't obviously farm if you don't have a consistent water supply. Now, on top of that, I remember, I want to say in like 2010, we have canals that would transmit the water to the farmers, but it was also used to get the water to the cities. Well, if there's no water to get water to the farmers, we didn't have water to get it to the cities. That we call that push water. So we were in problems. We had problems there trying to get water to people. So that's a real challenge that we had back then. And all you can do is, in cases like that, get compliance from your country, your neighboring country with your treaty. And how do you do that? Do negotiation, or do you go to war? I mean, there are really different ways to get countries to comply. You don't want to do that. But transboundary water is an issue, and quality transboundary water issues are a problem for any nation that shares water with other countries. So I just wanted to say that. And a couple of quick things. The problems we're having now that where I work, PFAS is going to be an issue for everybody. Here in Austin, we used to sell what do you call it? Compost made from people's yards. The utility would collect it. We don't do that anymore, so that's stopped. And then, but here where I work, we've got a site that's got PFAS in the groundwater. And although we've done testing and we say like, oh, you're good, the water's fine, guess what? The people at that site don't want to drink the water. So these are some of the issues that you have. And then Shri mentioned this earlier, water availability. And I talked about that earlier, but I read somewhere that if we go 6 years without water in Texas in a severe drought, there's not going to be any water. So that's a big issue. In 2011, we had some major drought issues, and we had pipes in East Texas that were cracking, even though they get 58 inches of rain a year, because the ground was shifting, and then people weren't getting their water there. So I think climate change and PFAS are going to be two regulatory issues to focus on in the future that we all have to worry about.
All right. Thank you very much. So I know they probably highlighted some of this, but briefly, do you have any of these issues or any of these problems, either technical challenges or regulatory issues, that are ongoing and recurring in water utility? Shri?
So again, the drought is an ongoing issue for us, right? Our with water shortage. So we are always trying to see how to manage that, right? How to obviously look for additional resources or the conservation, and then obviously like Steve mentioned, the new regulations coming from EPA, right? Managing that's also a challenge, not only from the point of new regulations, but with the climate change, right? It's either too hot or too wet, and then it not having enough. That also changes the water quality in the river. So how do we deal with that, right? That's been also a constant issue for our treatment plant. So the biggest, I would say, is the managing our resources. And then with all the, we have to deal with not just us, but there are other states, right? So we are constantly working to see, how to manage the river. But we, how the decisions made there, how they impact us.
Thank you very much, Shri. What about you, Michael?
Again, I guess as far as our ongoing issue, so obviously consent decree, it's drives everything we do. Practically everything we do is driven by consent decree. And one thing keep in mind is we've got the 4th largest sewer district in miles of pipe in the nation, about 9,000 miles of pipe, and a combined third sanitary, a third storm, 7 treatment plants, several hundred pump stations. So meeting that consent decree is is the challenge. We did have one, actually had 3 opportunities to renegotiate the consent decree. I think it's testament to our success in meeting the consent decree, which again, not everybody, as Steve alluded to, not everybody can brag about that. There's very few people actually can brag about meeting the CD that size. But we were able to negotiate. One reason we did was for our incinerators. And so we were applying, because you got to deal with sludge. You got a treatment plant, you got to deal with sludge. And you're really down to 2 choices. Steve got this a little bit. You got land application, you got incineration. You can do some things for land application before, but it still goes on the land. And we go with incineration now, and that it's ended up to be a great choice with the PFAS issue coming up, I think. So we did renegotiate our CD, in essence, move some projects back because we had to move our incinerator replacement up to meet, independent of PFAS, to meet updated regulatory issues. And so our incinerator project's now the largest project we ever did. It's $1 billion to replace 2 incinerators at 2 of our plants. So again, meeting our CD, but there continues to be these little things, our big things come up. We've been able to adjust the CD to keep meeting that. So I see you have some further questions about upcoming challenges, and that's a good place to talk about PFAS and all that. But yeah, there are several things on the horizon that may impact the CD, maybe not. But we're just trying to get through it right now.
Thank you, Steve.
Yeah, and before I go any further, I saw that Walter Grayman was on, and so was Avi, and these guys are really distinguished members of E.WRI, and they probably, you know, can laps around what I can say. And I think Avi's in Israel right now, so it must be like 2 in the morning over there, or maybe it's just 8 o'clock. I don't know what time it is, but in any case, I'm glad that both of these guys are on here. And Walter was the chair of the technical XCOM of E.WRI for a while. Let's see, or maybe it was the other XCOM. I'm sorry, Walter. I probably bangled it, but I just want to say a couple of things. I had to deal with these small communities in Texas, and a big challenge for them is that they just don't have the capacity to deal with drinking water regulations. The sampling you've got to do, and it's not very much there, but they don't have the capacity to apply for grants. They don't have the capacity to just maintain the system. They're so small, some of these, because a public drinking water system, by definition, under the Safe Drinking Water Act, is only 25 people or more, or 15 connections or more. I had one facility, one community I was dealing with that only had 10 connections, but there were 29 people. So you can imagine one house had like 9 people in it. I don't know. But one of our state representatives got involved. And so in order to please her, we were jumping through hoops to get these folks water. And it was a very complicated issue. So that's the problem we have with small communities, is they don't have the capacity to really deal with what they're trying to do in terms of maintaining the system to meet regulatory compliance. And let's see, again, water and the way it comes is going to be an issue. And sometimes we don't get any, and sometimes we get it all at once. And then when we do, it's just a huge problem. And I know that when I worked in Birmingham, I think in the space of 24 months, we had 2 500-year events, flood events, precipitation events. And so the weather, what's happening, they say, is that fronts are not being pushed through, they're stalling. And when you have that much rain in a small place at one time, you're going to have problems. And, I remember a couple of years ago, Pakistan, there was so much precipitation, they basically had a 100-kilometer lake formed. It's hard to plan for events like that when you have climate change issues. So in any case, I just want to say those are things you have to plan for, but sometimes you just can't. but you got to keep on the horizon for that.
Thank you very much, Steve. So these are a wide range of problems that you've all mentioned, from conservation issues to financial and compliance issues. But what are the primary resources that you would often turn to solve some of these challenges? Sure.
So the primary resources, first, obviously we look at the in-house, right? If we have any expertise in-house, to deal with these issues. Then we also look at the literature, right? There's if whether are any academic or literature or the publications or any work that has been done previously. Then we also, work with the leading, to reach out to leading utilities and researchers, to see if we can, get handle of some of the issues. Sometimes we may, have to go to the vendors, right, and then engineering consultants, because it may be a new equipment, a new software that we need to, deal with some of these issues. So that's the order. For example, we're trying to, we have a water quality issue. One of the things, back in 2005, right, when a new THM regulation came in, we had to look at and see how do we, it used to be a system-wide average for THMs, right? Then it became a localized average. So then we had to make sure, because we take water from lake, we pump it all the way to, lake is at right now 1066, but we pump it to 4125. So it goes through several reservoirs. So we had to keep the water age and then the THMs low, as low as possible, so that we don't have high THMs, right? So we had to come up with a way to manage. So we developed, we worked with some researchers and also internally, right? And then we developed a software system that's our digital twin, so that we optimize the water quality in the system so that we are meeting the regulation. So that when the 2006, when they adopted to localized THM values, we are still meeting at every location the THM limit. So again, for that, we have to do our own internal work, right? And then we also have to see what's available. And then we also had to work with some software vendors to develop that system.
Thank you, Sri. What are your thoughts, Michael?
So as I mentioned, obviously, I talk a lot about the CD. So there was no way that we were going to be able to meet our CD requirements without hiring engineering consultants and contractors. So we've, in the last 10 years, probably spending something like $250 million a year in construction fees. And obviously it all had to be designed. All that had to be in design. And when I say designed, that starts at the very first, right at a planning level, right? So we had to do all sorts of modeling, data collection, radar rainfall data, monitoring of the sewers, right? As Steve alluded to, CCTV, we've TV'd so many miles of sewers. I'll tell you, they never tell you in school you'll be looking at dirty videos of sewers, but I spent a fair amount of time looking at dirty videos. So we'd had to rely upon the consulting community. Just as a public agency, we weren't going to staff up to do that work. For example, we've removed, people would have like their downspouts going in their sanitary sewers. We don't allow that anymore. So I had to go out to each house, maybe smoke that, maybe TV it to find out what that is, come up with the drawing how to do it. That's 60,000 houses alone just for that one effort we visited. So, about 1,000 people at the district, most of them in our ops department, maybe about 200 engineering. So we the consultants you would recognize, Black and Veatch, Jacobs, all those guys we use. And now we're kind of through a lot of heavy design work. We're moving into the building it all. So we've got several large tunnel projects. We've got contractors from all over the world coming to help build all the stuff we've designed. So even last thing I'll go on, some of these resources we've used, it really all over, since we cover both the wastewater and the stormwater side. You know, for instance, we rely upon USGS for rainfall data. So we have a contract with USGS to get the rainfall and the stream gauge data from them. And so that lets, obviously, to calibrate all the models. So it's a lot of connections, a lot of players, and we got to bring them all together. So Steve?
Yeah,
Steve?
thank you. I think there are a lot of different resources to use, and it just depends on the problem. But I know one thing is that when I was in Jefferson County, we hired our asset manager and management company. They found an Australian firm that did some unique stuff, and so we gave them all our information. You know, our proposed projects, when our different basins, that is to say, where the sewer went, where the wastewater went, and how much it cost to fix them, and how much we needed to spend. And they came out with a model that was, it said, okay, this is how much you can spend. And the more you spent, the less bang for your buck you got. So you had to figure out which, and it told you which projects were going to work the best for what, amount of money. And then we could actually use some logic to that to figure out how to solve the problems that we needed. Where do we need to invest and put our resources? And that is great in theory. It's just then you also have what I call politics. People will call you, and this is something you're always going to have to account for, or the public. And I remember one time we had a discussion about we were going to do a plan because we had a pump station where we had odors, and we had a carbon media capture system to reduce the odors. And we had a discussion. What do we, how do we do? And, how do we fix this? And like, we don't, I remember one of my coworkers said, like, odors, we got odors, no big deal. When I go down to the beach in Florida, I got to go past the wastewater treatment plant, no big deal. Guess what? The very next day, somebody called the county manager and complained, and we swapped out the media that day, $60,000, boom. And that was unplanned. So you've got to take into account politics. In any case, that's just, I'm not speaking to what you're asking necessarily, but I'm saying you're going to have to take that into account when you do plan. And I know that when I was at the state and we were working on Rio Grande issues, I worked with faculty at the University of Texas all the time to try to solve some of our issues, especially salinity. In the Rio Grande, we had a lot of irrigation return flows from Mexico, and that basically made the water very high salinity levels. And if your salinity levels are too high, you can't reuse the water, and it just tastes bad, and people don't want to use it. And people would spend a lot of money getting 5-gallon buckets, containers refilled, rather than drink the water from the faucet, even though the water met Safe Drinking Water Act standards, because it just had high salinity levels. So we would enlist help from some researchers at the University of Texas. So there are a lot of different sources to use.
Thank you very much, Steve. So you've all, while talking about some of these issues, I know you've all mentioned PFAS. But what emerging issues of concern do you foresee in the next 15 years, specifically when it comes to technical and regulatory areas? Sure.
So I think one of the major issues, at least for water utilities, right, the aging infrastructure. So we have the infrastructure has been aging, and then there's not how much amount of money that needs to go in, right, to repair this, to make sure we have enough money. We have to make sure that we also need to manage the rates for our customers. So which means we have to make sure that we increase the longevity of the existing infrastructure, and then we have to manage it, right? That becomes, so one of the things, for example, we always try to see how to protect and then increase the infrastructure longevity by one of the things we do is we look at all the transients. So we have been working with researchers and in fact a vendor to do an automated transient analysis. So we can look at and see where different scenarios, how we get transients. And then when we, as I told you, we have a digital twin that our operators develop a pumping plan every day. So we incorporate into that pumping plan so that we don't get these transients in the system, so that the infrastructure is protected. We also, when they load the plan, we make sure that there are no high pressures in the system, right? So, and then again, to increase the longevity of the infrastructure. So one of the things, like, how do we manage to the investments in infrastructure, right? And then aging, and how do you add new facilities and also protect the existing infrastructure? I think that's going to be, that's a lot of money, and then that's a lot of, obviously hydraulics and management techniques and all of that going asset management, right? That needs to be done. So that's one thing. The second part, I think, is the aging workforce. In water industry, people have been retiring much faster than the people coming in, and the knowledge. So I think that's another challenge that we would have. And then the third one, I think, is the climate change. It's either too hot or too wet, and how do you adopt existing infrastructure, and then design future infrastructure to be adaptable, right, to risk and uncertainty, and then be sustainable. So those are the three I see, Michael.
Very relevant. Thank you very much. Michael?
When I was preparing for this and you shared the questions with me, I came up with about four things that I think are going to be of real concern to wastewater utility like mine, and stormwater, wastewater and stormwater. First was kind of just mentioned, and Steve kind of talked about it, to this whole issue of asset management. We've got all these pipes and all these sewers and infrastructure. How do we take care of that? And what I think there's a great opportunity here, and civil engineers hopefully can take advantage of and stay in the far forefront. But I think this where artificial intelligence, machine learning, and the term asset management. Asset management has kind of been out there since I graduated. And usually there's some guy up in a corner office that does asset management. It really doesn't trickle down the way that it should into to ownership and operation of most places. And that includes the DOTs I've worked at and other agencies. So I think there's great opportunity there. The second one is obviously the PFAS. And again, for wastewater agency, that applies to disposal of sludge specifically. There's all sorts of other things. And there was just a recent article here I downloaded that, state of Maine passed the land application ban. They're saying you're not putting no more sludge on land in the state of Maine. Not going to happen. And the EPA has not issued particular good guidance on the issue. So there's a lot of frustration amongst, I think, a lot of people with the EPA, and they've even made the statement that that they may not have regulatory authority for PFAS. The statement from Dominique Joseph, Senior Communications Advisor to the EPA, the presence of a pollutant in sewage sludge does not necessarily mean that there is a risk of human health. on the environment from its use or disposal. I think most people kind of laugh at that statement with regards to PFAS and sludge. Third, the issue of climate change, especially as related to the stormwater side, and also how that may impact maintenance, sizing of different BMPs in the system, right? You just got a BMP, hope to last, at last. And then, of course, in St. Louis, we're right on the Mississippi River. So you've probably heard the term Gulf hypoxia, right? Gulf hypoxia. That means there's no oxygen for the fishies down there in the Gulf of Mexico. And that's generally related to phosphorus. So we've had a lot of regulation from the state, and we've had to do a lot of work to a lot of our treatment plants, to our publicly owned treatment plants to address phosphorus. So that's kind of four. And I would just echo kind of what Sheree said. Not much technical aspect, but a lot of the challenge we've had in the last several years have to do with an aging workforce, being able to hire. You throw COVID in there, inflation, supply chain issues. It's been an interesting time to live in. But those are more the management sides, but they definitely cause a lot of heartache. That's about it.
Thank you very much. Steve.
I think the things I would mention that are the most significant were touched on by the previous speakers. Maybe I mentioned it too, is especially PFAS and climate change. And that's not a regulatory thing, climate change, but it's an issue. And I mean, we have drought maps in Texas, and depending on how much rain we get, we go in and out. But I'm telling you, 6 years of drought in Texas is going to cause severe problems. And the problem we have in Texas, people keep coming here. And like Shreya's found out, they've got a finite amount of water, but they've got more people coming in all the time. And they've done a really good job in Nevada. And I think they've got they manage it. They can do that. But in Texas, you've got 6,000 public water systems scattered throughout the state. So it's hard to get them to do things, even though they've all got to come up with a water conservation plan. Actually clamping down on them, is hard to do because everybody likes their green lawns. There's an article in the New York Times a couple of years ago. I need to find it, called "Kill Your Lawn," like get rid of your lawn, xeriscape. And I think that's going to be the future, because we're not going to have any other choice. And I think that's all I have to say. I mean, I could talk more, but those are the most significant things.
All right, thank you very much, Steve. For the next question, would like to know, in the past, present, or in the future, how has your utility company or agency procured any research services, or specifically, does academic research help you address any of the challenges that you've all previously mentioned? Shuri.
Yes, so we have definitely used the research services in terms of optimizing our system in water quality, right? I know, Steve, you mentioned W.D.SA and in Walter here. We have, used not their services, but their work they've done in terms of academic research. Again, one of the things I mentioned, our digital twin, is a result of a lot of research that we have done internally, and then the research that we have used from the academics, right? As a result, I think we got, we have been using that since 2005, right, to optimize water quality in our system. We have cut down energy usage by 15%. So we use about $15 million, right, for the energy in 2005. We've been, consistently getting savings from it. And also the bigger benefit is to responding to emergencies and in optimizing our infrastructure. So to answer your question, yes, we have used the research. We even got, I think, from those works, we got 2015 and 2022 papers, best paper awards from F.EWRI. In terms of, also, I just mentioned that we are working with researchers on using the transients. How do we protect our system, right? Analyzing transients, and how do we protect so that we increase the longevity of our infrastructure. So one of the things we also, for example, we're also using AI and ML techniques, right? Again, we are looking at the research that's being done. For example, we since once we load the plan, we know how the system is supposed to operate, and then we're using AI and ML to see if there is any anomalies in the system, and then catch them quickly so that we protect our infrastructure. Right. So to answer your questions, yes, to both of those. Michael.
Michael?
Sorry, I was trying to unmute myself. So yeah, again, I mentioned the CD several times. So we're kind of in a spot right now where we've negotiated this and we're meeting it. So at times we feel like we don't really want to mess with the answer we got, so to speak. So we certainly did a lot of research previously as consultants, our reference research, but and there's things that keep coming up, so to speak. But some of that's probably died down as we're more in the construction phase of that CD, right? If we got $1 billion out to bid, the last thing you want to do is start going back and doing research if that's the right solution, so to speak. So some of the research we've definitely used and sort of continue to use related to stormwater BMPs. There are some state testing, or different universities do testing of performance of BMPs, referred to as a technology acceptance reciprocity protocol, TARP, on the East Coast, and TAPE, technology assessment protocol ecology, then also on the West Coast. We use them. We've used so to kind of state run our private laboratory run research. We've used research from local academics, kind of partnered with them to do research especially related to the phosphorus issue I mentioned. And we're starting to do that a little bit more with PFAS. So we'll actually might have a small contract with somebody. We've also rely a lot on the EPA and Missouri DNR, right? So their research, so we're always trying to stay up to date on what their research and where the rules are heading. And then finally, just the one that's perhaps a little more entertaining. So that, for lack of a better word, every once in a while we'll have because we do have these relationships with different professors. They'll have a student have either for their senior design, which not so much research, but they'll have a master's student looking for a project, so to speak. So we had one here recently, a young lady from Missouri S&T. I got your shirt on. My alma mater, and she did some research. We talked, and she, what can you do, boy? Now that we've been doing these BMPs, stormwater BMPs for, since '97 in our area, we kind of like to know how they're going. In particular, which ones kind of went well, which ones didn't. If there are certain metrics she can look at, to kind of predict what's going to go good and what's not going to go good. So that's kind of just more fun, just more of a personal relationship drove that. Again, we've definitely done that. Maybe not as much right now, because we're engineers. We gotta do something at some point. But I just think these issues aren't going away, and things like climate change, PFAS, phosphorus are just getting more and more complicated. That's about it for me.
Thank you. Steve.
Yeah, just wanted to, I put in the chat, David Eaton was one of my professors at the University of Texas, and he's actually got a project working now with the state of Texas to do salinity research with graduate students. So the answer is yes. But I'll leave it at that. So
Okay. All right. Thank you. Thank you very much, Steve. I think the link is also helpful to kind of read more about how you've been able to use academic research in your work. So lastly, is multidisciplinary research of benefit to your utility? I'll start with Shri once again.
Yes, multidisciplinary research definitely benefits, right? Many problems are multidisciplinary in nature. Also because of the advancements in technology, right? Now, some of the problems you can approach with the technology. A good example I can give you is AI and ML, right? Now, so one of the things, I'll give you an example of our digital twin, right? So the digital twin, when we developed, it's not, if you look at purely, if somebody looks at it, it's a hydraulic, model, right? The prediction, but there's a lot of, information that comes from several sources, right? So it comes from SCADA, it comes from corporate data, and then so it also an IT problem, right? So how do you combine those? And then also you have to take into account how the utility functions. Putting all of them together, you need a multidisciplinary approach, right? And I think the reason it's been successful, we have been running since 2005 because we've taken a multidisciplinary approach. I've as I mentioned, have some background in IT, computer science, right? And I also have engineering, but also we pulled in people with the every discipline to make it work in terms of water quality, in terms of energy optimization and things like that, right? The other example I gave you, I think before, is how are we detecting anomalies in the system? Once we load, right, we are monitoring pressures, but we are also, that's again an IoT device that we are using, right, and then also SCADA. How do we detect and then use the AI and ML techniques, right, that are most recent? How and then how do and then protect the longevity of the infrastructure. The other reason I think also, the multidisciplinary, with the climate change and then the other issues that we just discussed, the problems are becoming more and more multidisciplinary. So I think the benefit with the multidisciplinary approach is if you don't use it, you put problems in isolation, right? When you try to put together, either, they don't work or they're not optimal. So to get the optimal benefit and to make them work, I think you have to take multidisciplinary approach. Michael?
Thank you, Shri. Michael?
Yeah, I would echo again a lot of that. So it can be surprising some of the relationships you come up with as part of our phase 2 permit. So for the stormwater side, my previous position I had particularly involved in that. And, an example that came up was to meet our permit, we had to research the impact of BMPs to a community. I guess with the thought being that putting a nice community garden or something out might help, especially as be a positive for area, especially as related to something Steve kind of hinted at, the whole environmental justice side of it. And so again, when you've got a CD and our rates keep going up and up to meet the CD, that obviously has a lot of impact on ratepayers, and certain people maybe not in position to pay. So so anyway, the specific example I talked about with Jinaping Zhao, who I think is technical XCOM chair right now, was out at SIUE, and he ran a project and got in his economics guys from the university, from the economics department, and we got some landscape architects guys in and researched the impact of these BMPs upon the local environment, and that just came to mind. I know because I know Jim's pretty involved with E.WRI right now. So yeah, these things come up. It is just always kind of interesting, and I got to admit, some of them are even like, oh, didn't see that one coming. You know, some of these relationships you develop are kind of odd. You know, and the last example used for me personally, again related to BMPs, is we did a lot of work with Missouri Department of Conservation, but also we have here in town the Missouri Botanical Garden, which is apparently, if you're into such things, I'll just say that at one point apparently they gave the guy in charge of Missouri Botanical Garden to offer to go run the Smithsonian. He turned it down because he thought it'd be a step down. So they've got a research. They go all over the world and do different research. So we actually paired with them to partner some of the green infrastructure issues. So there are some examples that have come along.
Thank you, Michael. Steve.
Yeah, I'm going to put something in the chat, but just to give you a quick idea on multidisciplinary aspects, when I worked at the state of Texas in 1993, we were concerned about we were trying to get the North American Free Trade Agreement passed, and someone was concerned about, there was a cluster of, I'll try to be brief, of babies born with what do you call it, anencephalic babies with missing brains, and a doctor was alleging it was pollution coming into the Rio Grande from Mexico. So we did a study with several federal agencies, including FDA, EPA, and we chose 9 families in the Lower Rio Grande Valley. We did ambient air monitoring. We took soil samples. We vacuumed the dirt in their house, and we also took a plate of food from each of these 9 families. They set an extra plate of food, and that was shipped off to FDA to analyze. One of these plates of food had a fish on it that had the highest levels of PCBs ever found in North America, 350 parts per billion. And it was staggering. So we went out there and sampled it, and yeah, there were a lot of hot fish in the Donna Canal, which it had come from. 15 years later, this became a Superfund site. So there was an example of, different agencies working together and different kinds of sampling to get something done. So it's not always that way, but I think you really need to work with a variety of different people. And so it's kind of crazy that I worked on a project that became a Superfund site, but it took 15 years. So I just thought that's an illustrative case, and I just want to share that with you all.
Thank you very much, Steve. So very briefly, and this is the last question, do you find yourself working on this multidisciplinary project by yourself, or do you have different aspects being given out to corresponding experts and agencies and authorities to collaborate with you on this? Sherry.
So we do reach out to people, right? Experts. Obviously, you're not expert at everything. One of the things that we also work with several vendors, when I say vendors, equipment manufacturers, and also the software vendors, in addition to the researchers in the field. We reach out to them. Sometimes, it's a new equipment that comes, a new product, right? We're also, internally, researching with them, because sometimes the problems are unique to your own utility, right? That may not be applicable to everybody, but sometimes working with the vendors and the software vendors, and the equipment vendors and researchers, we can find, again, you have to reach out to individual experts, right? And then we find solutions.
All right. Thank you, Shri. All about you, Mike.
Michael.
Yeah. I think that's one of the neat things about civil engineering. And, you know, engineers can be thought of as maybe that job is kind of boring. Our lacks differences, or so to speak. But I got to admit, you know, over my career, I've spent plenty of time on construction sites. You know, I've worked in a lab, I've worked in an office. So even to this day, I carry in my car waders, 5 buckles, a manhole hook, and a sports coat, you know, jacket, because I don't know if I'm going to have to go on a meeting with the jacket, or if I'm going to have to be pulling a manhole in a given day. So, so that variety I do that, and I still get to do a lot of that, and that's one of the reasons I have stayed here for 20 years now. But so I think that's something that civil engineering really lends itself to, and that we as civil engineers, when we're trying to recruit or brag about a profession, that we really need to let people understand, because I don't know many people as adults, you know, say if they're in the computer field or in banking or whatever, that have worked in as many different environments as I personally have, or with as many, you know, everywhere from mayors and consultants, you know, all the researchers, all the way down to ditch diggers, right? And so really been blessed to do that, and it's made my life a lot better. And I don't think we share that enough. That's my 2 cents.
Thank you, Michael. Steve.
Yeah, I just have found from my experience that you've got to work with everybody. So otherwise you don't know what's going on. And you either share with people like, hey, this is what I learned, or you bring everybody to the table together. That's the best way to get things done. And what do you call it? Synergies. You have synergies when everybody gets together. So it's important to do that. And I you know, you can farm things out, but eventually you got to bring everybody together, and that's the way to get the best solution. Because you know, you get people together, and suddenly go like, "Ooh, this occurred to me." And you go like, "Oh, that's a really darn good idea." I don't have any examples right now, but yes, you know, you work together.
I can give an example. So 20 years ago, right, we were trying to get flows through a PRV because we wanted to see what's happening in the system, right? So we know that from the instrumentation that we have, hydraulics wise, if you know the percent opening of a PRV and then upstream and downstream pressures, right, you can get the flow. But how do we get that to a computer in our office so that we can constantly get it, right? Because we have several of them to put a SCADA and all of that. It's really expensive. So we went to a vendor who was doing similar thing in gas industry, right? But they only, send the pressures. But then we had to go to a valve vendor who can, give us the percent opening. So with working with all of them, we came up with a solution where we got the data, not only the percent opening from the valve, right, the equipment manufacturer, but also, the pressures from a cellular communication device that we were, from another vendor. And all of that, then we had a software that combined it together and then got the flows. Now I think they regularly use it, but I think that's just an example how you have to go, to different people to get the solution that you want.
Thank you very much, Shri, Steve, and Michael, for sharing out, giving out your time to talk about, or giving us an expose into the industry and how you've been able to solve some of the problems, as well as the problems that you foresee in the future. We also thank you for the practical examples you've given us to kind of bring out the main point and help us see the main idea of the questions. We have a few questions from the audience, and I'll just ask a few of them. So Walter had asked, during the recent fires in LA, there's been a lot of criticism concerning availability and delivery of water, much based on misinformation. Do you have any comments as regards that?
If I can start, one of the biggest things when we look at the infrastructure, Walter, is the fire flow availability for the system. So whenever we approve, one of the things that we're working with the developers or the builders, right, what infrastructure is needed is, do we have enough fire flow? So we constantly work with the fire departments, at least in my utility, right? We may ensure that that we have the required fire flow. Sometimes we also look at the redundancy in terms of, let's say, we lose one of the pipes, right? Do we still provide fire flow availability, right? So we're constantly looking at this. Again, what they had is, probably not something that you can not, predict, right? But I think just to say that every agency, again, I don't know the situation in LA. That's a requirement. It's a for example, it's a state law that we have to actually look at. We call it M.ASCE, that we need to make sure that when we have a new development, that we meet the fire flow requirements.
I have to admit, I'm not on the water side. I've wastewater and stormwater. I appreciate Sri's comments here about your design. It's a little bit, I've talked to people and the maps I've looked at. I admit this really irks me that some of these statements that are made. You design for certain things, right? You design for a building catching on fire. You design for a fire, and you size for fire flows. You do not design for this whole city burning down. And yes. I think it's just criminal for some of the things that are kind of way this being painted as sort of a failure. So I did it just because I'm a big nerd. I spent quite a bit of time studying the Fukushima plant, right? And so Fukushima failure, and there's been some talk on that, but a beyond design basis event. It got hit with a tidal wave. They didn't plan for that mega tidal wave. So the fact that they can't put these fires out, to me, from what I understand about design, and I'm kind of the head designer in our agency, you can get a lot of credit for that. They didn't design for this, and you couldn't have expected them to design for this. This is a question beyond, was the water available? Was the system sized properly? This is just so far beyond that to paint it as a fault of the LA Water Department and our local politicians. Obviously I feel strongly about that. I think it's absurd. That's my 2 cents. I could be misinformed, it could be wrong, but I hold it with sincerity and fire that makes up for any wrongness.
Okay, thank you very much for your comments. Also, Aina Crozier, I think this question is directed to you, Michael. You mentioned that repairs take up a lot of time. Would you mind sharing some more information on this? For instance, is it mostly pipe breaks? Michael?
I'm sorry, I didn't realize I was muted. Yeah. So a lot of the infrastructure repair we're doing is pipe breaks, inlet repairs. And so why this gets to be a challenge, if I could share my screen here, here's a good example. So we'll get projects identified by the operations department, because again, they're TV and all this pipe. Can y'all see that?
Yes.
Okay, so you can see these pictures here. Is that what you're seeing?
Yeah.
Okay, so this project was identified. So they put TV in there. You can see the exposed dirt, all right, the poles. So that old brick pipe, which again, a lot of our pipe is old brick, has failed. So, all right, so you got to replace it. All right, that's easy, right? Well, this is where this pipe is. This is millipore sigma. See, that's our manhole. This is probably one of the most expensive industrial facilities in the city, and our pipe's underneath there. So I go into millipore sigma. I'm going to dig this up and replace that pipe, fix the holes. They're gonna have to laugh at their life when I tell them that, right? Because no, you're not. So now, don't fix the sewers really, and then on top of it, you can see right there's a retaining wall. So the pipe's really kind of underneath the floor and next to a wall. So repairing that in place is pretty well impossible. So now, what might simply be a point repair, we've got to acquire easements. We've got to negotiate with that owner, acquire easements. We've got to model and design and come up with construction plans, get it bid, built. Again, now you're in this expensive industrial facility, so you're going to have to do bypass pumping. You're going to have to deal with whatever they're putting in the sewer, which is probably under some sort of a permit, industrial waste or pre-treatment permit. So it's the joys of having an old system. We're actually looking at probably some kind of segmental slip lining for that is where I think we're at right now, but who knows? So that's what makes it hard.
Thank you very much, Michael. Thank you very much again to all of our speakers for the time you've given us to talk about these issues within the water resource engineering space. We also thank everyone for attending and giving us your time as well to join our community for this webinar. Please feel free to check out our social media page on LinkedIn, on Instagram, and on YouTube. You can also join our mailing list using the link on the screen. And please also, we'd love to hear what you think about this webinar. We also love to hear what you think you'd want to see from us, what topics you'd like us to talk about, or what speakers you'd like us to have to talk about certain issues in our upcoming webinars. So in the absence of any additional questions, we'll thank you all once again for joining us, and we'll call it a wrap for the webinar. Thank you all.